Up to this point, we've looked at functions that have always remained positive, but what happens when the function dips below the x-axis? If you consider it in terms of Riemann sums, notice that when we calculate the area of these down here, we're actually going to get a negative number because the function value will be negative and we'll have delta x times some f of c, where this f of c is a negative number, resulting in an area that's negative. However, we know that area, much like distance in terms of absolute value, has to be positive. So let's consider how this changes our idea of area in an integral. If the function is positive, in other words, it's non-negative on the interval AB, then the total area under the curve is the integral and is bounded by the x-axis. In contrast, if the function is negative for any x within that interval AB, then the integral actually represents the difference between the areas above and below. So for example, if we consider this integral here, notice that we are calculating the integral between 0 and 2. This is going to remain positive for all x values. When we do the antiderivative, we get x squared over 2 plus x. We're going to calculate it from 0 to 2, resulting in 2 squared over 2 plus 2 minus 0, which gives us 4 over 2 plus 2, or a total of 4. It's a total area. In contrast, though, if we consider this function that falls below the x-axis, and again, we're trying to calculate the area between 0 and 2, it's fairly easy to see that these are actually equal. When we calculate this antiderivative, we get x minus x squared over 2. And if we calculate that from 0 to 2, we get 2 minus 2 squared over 2 minus 0, which gives us 2 minus 4 over 2, which is 2, or an area of 0. As we stated before, when it falls below the x-axis, the integral itself is actually the difference between the area above and below. And while we're able to find the difference of the area, what if we want to find the total area? Well, notice we would take this second part and we would simply add the absolute value of it, or the negative of that area, to the other value to get a total area. So let's consider something like this. If we want to find the total area bounded by 4 minus x squared on the interval from -2 to 3, notice this portion is negative. We can therefore break the integral into two parts and take the integral of 4 minus x squared from -2 to 2. This is the portion that's positive. And then we can also, that will give us one area. And then we can also take the negative of the region from 2 to 3, because since this is going to be the negative number, if we take the opposite of that, we'll get a positive number, and then we can add them together. Performing this integration, up top, we get 4x minus x cubed over 3 from -2 to 2. And I'll allow you to go back and plug those in, but if you have questions, let me know. When we calculate that value, we get 32 over 3. When I calculate this integral, I have 4x again minus x cubed over 3, and all of that's going to be negative from 2 to 3. And when we calculate that, we get negative and then a negative 7/3 inside, resulting in 7/3. So in order to calculate the total area, we would take A1 plus A2, giving us 32/3 plus 7/3, which gives us 13. Now, in contrast, if we wanted to find the distance or the difference between the two areas, we would simply take the integral from -2 to 3 of that entire span instead of two parts, which would give us the A1 minus the A2, which is going to result in 25/3. And we get that from the 32/3 minus the 7/3. Some important properties that extend from this are the idea that we can flip that integral. So notice this first one here, we're going from A to B. The negative of that integral will be the integral from B to A. And likewise, what we did in that initial example is we split the interval over two parts, and we're allowed to do that and add the two pieces together. This can come in very handy when we're dealing with piecewise functions. So for example here, if we wish to find this integral, notice we can't do it solely over one region. So if we want to find from -1 to 2, we have to go from -1 to 1 using this function. And then we would have to add the integral from 1 to 2 using this function. And based on that property, we are allowed to do that. Calculating this integral, this first part would give us x squared over 2 plus 2x, and we'll calculate that from -1 to 1, plus 5x minus x squared from 1 to 2. Performing those pieces separately, we end up with 1/2 plus 2 minus 1/2 minus 2 for our first integral, plus 10 minus 4 minus 5 minus 1, which results in 5/2 plus 3/2 plus 2, or 8/2 plus 2 gives us 6 for the area under that piecewise function. Where this can come in handy is the idea of marginal analysis. Remember things like marginal profit. If we take the antiderivative of marginal profit, we get the profit function. If we take the antiderivative of marginal cost, we're going to get the cost function. So in this example, imagine that we have a marginal profit function of 20 minus 0.05x, where x is the number of items sold. If we want to find the profit for selling the first 200 items, we're going to take the integral from 0 to 200 of that function, 20 minus 0.05x dx. And when we integrate that, we get 20x minus 0.025x squared. And we're going to evaluate that from 0 to 200. This gives us 20 times 200 minus 0.025 times 200 squared minus, notice again, this is going to result in 0. And when we calculate this, we get 4,000 minus 1,000 equals 3,000. This does not take into account any fixed costs, because what we're actually calculating here is the change in profit from 0 to 200. We could also then calculate the change in profit from 200 to 600 items by going 200 to 600 of 20 minus 0.05x dx. Notice we're going to have the same antiderivative as we did before, but this time we'll be evaluating it from 200 to 400. We know the value when we plug in 200 is 3,000. So when we plug in our 400, we have 20 times 400 minus 0.025 times 400 squared. And then we can simply subtract the 3,000 that we already calculated when we plugged that value in. This results in 8,000 minus 4,000 minus 3,000, which gives us a change in profit from 200 to 400 of, and I'm sorry, 200 to 600 of those items.